Hi and Assalamualaikum everyone. My name is Ahmad Fahmi bin Muhammad Saifuddin and I'm from Group 1. Today I'll be explaining about Experiment 12. Before that, let me introduce my team members. Firstly, there is Muhammad Baihaki, then there's me, Ahmad Fahmi, next is Tan Ka Hui, and lastly, Sohail Jits. Rheology, defined as the study of material deformation and flow, finds application across diverse fields, including engineering, material science, and industrial processing. Within this discipline, fluids are categorized primarily by their viscous behavior. Newtonian fluids, which are relatively few, are characterized by a constant viscosity at a given temperature, unaffected by change in strain rate. In contrast, the vast majority of fluids are non-Newtonian, where viscosity varies within the applied strain rate, such as changes in flow velocity. Consequently, the central objective of these rheological studies is to observe the behavior of fluids, effects such as Weisenberg effect, Kay's effect, and Barrow's effect, in both Newtonian and non-Newtonian fluids. As for the materials used, we chose shampoo, hand lotion, body soap, and facial cream. And for the apparatus, we use rod, drills, syringe, petri dish, and crucible. Procedure number 1. Body soap is poured into a crucible, a measuring cylinder, and a syringe. For Kai's effect, body soap in the measuring cylinder is poured into a petri dish. Then the fluid behavior is then observed. For procedure number 3, next, for Weisenberg effect, a metal rod attached to a drill is inserted into the crucible containing body soap. The hand drill is turned on and the rod spins. Fluid behavior is then observed. After that, for Barrow's effect, a syringe containing body soap is used. The body soap is pressed out from the syringe and then the fluid behavior is observed. Lastly, step 2 till 5 is repeated by changing body soap to hand lotion, facial cream, and shampoo. This is the results for Kai's effect. This is the list of results for Weisenberg effect. This is the list of results for Weisenberg effect. This is the list of results for Weisenberg effect. This is the list of and this is the result for the Barrow's effect. And this is the result for the as the final result. For body soap, there is no Weisenberg effect, Kai's effect, and Barrow's effect. For shampoo, all three effects are present. For facial cream, all three effects are not present. And lastly, for hand lotion, only the Weisenberg effects are present. For Kai's and Barr's effect, it is not present in hand lotion. For discussion, based on theory, non-Newtonian fluids are expected to show positive result in tests such as Weisenberg's test, Kai's effect, and Barry's Dicewell effect due to their elastic and shear dependent behavior. From the experimental result, shampoo showed positive result in all three tests, indicating clear non-Newtonian behavior. However, body soap and facial cream did not show positive result in any of the tests. This may be due to their relatively low elasticity or insufficient experimental sensitivity, making the effects difficult to observe. In addition, handling errors and limitations in the experimental setup may have affected the result. For hand lotion, a positive result was observed only in Weisenberg effect, while no visible effect were seen in the Kai's or Barre's effect. This suggests that hand lotion exhibit weak non-Newtonian behavior where elastic effects are present but not strong enough to be clearly observed in all tests. Overall, the differences between theoretical expectation and experimental result may be due to factors such as fluid composition, viscosity differences, small sample quantity, and difficulties in observation during the experiment.
In conclusion, the experiment was conducted to differentiate between Newtonian and non-Newtonian fluids using three different tests. While the Newtonian fluids behave as expected, Some non-Newtonian fluids showed inconsistent results due to experimental errors and handling difficulties. With better experimental control, proper handling technique, and suitable sample quantities, the result would likely better match the theoretical prediction. The experiments still successfully demonstrated the basic difference between Newtonian and non-Newtonian fluids.